So I'm here from the Designing Responsible AI Technologies to Curb Misinformation, Disinformation core research program. And I'm going to talk about some of the latest work we've been doing using natural language processing tools and specifically generative AI systems to help improve the ability of human fact checkers to deal with these kind of rising threats. So I'm going to talk about the kind of prior work and the sort of overall goals of this kind of generative AI effort, and then I'm going to show you what the kind of tools we've built so far can do, and I'm going to talk a little bit about the research gaps for kind of going forward into the future. Okay, so a lot of the research in my group specifically has been looking at kind of related problem from a few different angles. So the kind of one of the big things that's been talked about in the context of generative AI is its propensity to hallucinate. ChatGPT has the ability to kind of generate stuff from its parametric knowledge, all the kind of basically the remnants of the training data that exist inside the parameters of the model after it's kind of consumed the web. And when it generates things, we would like to know whether or not they're factual. And it's gotten pretty good. You know, if you've used it extensively, you know that, you know, if you ask it about like famous people, it's not gonna like come up with stuff that's total crap. But there's still errors it makes and kind of very subtle things that go wrong, which we would like to check before these kind of things get used in high-stakes applications. So there was a famous case, for example, of it getting used by lawyers, and it like hallucinated and made up legal cases that they then included in a legal brief. I don't remember exactly what it was, and then they got yelled at by the judge for you know, being stupid. So this kind of thing requires a high level of automation, right? Like if every time you query ChatGPT, we'd like to kind of detect whether something's gone wrong, you really need to be able to run this at scale. The thing I'm going to talk about today is more in the second bullet here, which is a related problem. When people say things, not systems, but people, how do we go about checking that what they say is right? And I think these problems are actually converging in some sense where, you know, if we think about a political speech, a lot of times there's information that is kind of grounded in some sort of factual, you know, it's grounded in something factual like a scientific study, but it may sort of slightly misrepresent or get things wrong. And this is where it would be really useful to have generative AI be able to help people understand what's right, what's wrong, kind of really get into the nuance of it. And that's what we're going to be talking about today. Can large language models help with this kind of political fact checking? And specifically, can they be tools useful for human fact checkers? Like if someone is working at a website like PolitiFact, can they use these tools to help them more effectively sift through all the stuff that's being said, all the information about it, and figure out how to address it? So if we go on PolitiFact and look at the sort of process that the editors there use, they'll take a claim like this one. Joe Biden said, "When I was vice president, violent crime fell 15% in this country. The murder rate now is up 26% across the nation this year under Donald Trump." And there's a bunch of different sections in the PolitiFact page about this, which reflects a process that we call decomposition. We need to look at the different aspects of this claim and figure out what needs to be checked. So in this case, there's kind of these two obvious statistics. Violent crime fell 15% and murder rate is up 26% under Trump. So you might think, okay, like these are the things that we need to check. But in fact, there's another kind of key element here, which is the fact that we're making this comparison that's maybe not apples to apples. This really kind of comes back to the sort of key thing that the editors actually wrote about in this PolitiFact piece. And so there's this kind of below the surface level that we need to get to here as well. And then if I'm going to tell you as either a kind of reader of the news or someone working at PolitiFact who's using a tool, I might tell you that this claim is half true. That doesn't actually help you all that much, right? Because you don't know which half of it is true, right? Or what that even means. Instead, you want something more like an explanation. And here the explanation given, again, this is taken from PolitiFact, is, yeah, the violent crime fell this much, the murders have gone up this much, but Biden's crime is based on snapshots of different crime data and at different time intervals during each presidency. So there's sort of this element of like the data is a little bit cherry-picked, right? So that's where the half-true comes from, not that like one of these statistics was blatantly wrong. So we really, the second ingredient we need besides this decomposition is this ability to have what we call explainable judgments. So we produce not just this final judgment, but also an explanation of what's going on here. Okay, so this is the kind of framework that we're operating in. And so I'm going to talk a little bit about some of the work we've done, and then I'll show you a kind of demo of the tool. So this was work published at EMNLP 2022. What we looked at was the problem of producing these decompositions of a claim into questions that target these different aspects. So for example, in this case, we have what we call literal sub-questions, where we want to know, basically, are the sort of explicit facts of this claim true? More interestingly, we have these implied sub-questions as well, or questions that we need to ask that probe beneath the surface level meaning and get at these factors like, well, are these kind of statistics comparable? Are they from the same time interval? Are these two kind of murder rate and violent crime rate, are these things that we should directly be comparing here? So in this work, what we did is we annotated a data set of political claims with these kind of questions through a process where we looked at the justifications that were already there in PolitiFact, and we had annotators that we hired who were synthesizing these questions based on the judgments that were there. So basically, this was a sort of factor that was important, so let me kind of crystallize that into a question. And now this is data that could be used to either train or evaluate a system to do this kind of decomposition and produce these sort of questions. So there is a little bit of the kind of the process of like putting yourself in the shoes of the fact checker, thinking about what are the sort of factors that we need here and trying to figure out how to annotate a question based on this. And so, you know, what we found that was interesting is that across a wide range of political fact-checking settings, you actually almost always, or kind of the most of the time, you have a implied kind of aspect that you need to address. It's not just about the surface level meaning, there's something kind of more sophisticated there. And part of that's because the things that are chosen to fact check have these properties, and so there's a separate issue of how you kind of prioritize and triage all the things that are being said in something like a political debate to figure out how to, you know, what to address. We're not going to get into that problem specifically today. Okay, so that work, like I said, was done in 2022, and so I'm not going to talk about the results of that. Instead, I'm going to show you something that's a little bit closer to the system that you're actually going to see. Which is that we can ask GPT-4 or the kind of state-of-the-art large language models basically to do this kind of decomposition. And GPT-4 will do a really good job at surfacing a lot of different questions related to various aspects of this claim. So I know there's a lot here, but I wanted to give a sense of like how well these tools really work. So it'll pull up things like what years was the speaker, the vice president, and what were the violent crime rates during those years, right? So trying to make it precise, like when are we sort of talking about here? What are the sources available to verify the reduction in violent crimes? By what metric is this being claimed? And not all of these things are things that are actually important to check or are necessarily going to be relevant here. But I think they're all things that could potentially be relevant. However, it's still the case that of all these things that get surfaced here, there are a bunch of kind of claims about the statistical accuracy, but GPT-4 doesn't actually identify that this mismatch between the kind of time frames and the types of statistics might be a reason that the claim is misleading. So there's still kind of a little bit of work to do to get these systems to be able to do this fully reliably, but I don't want to say that they're just totally bad. If we look at another example, which I'll show you in a second in the context of our system, this is a claim when San Francisco banned plastic grocery bags, you saw the number of instances of people going to the ER with things like salmonella and other related illnesses spike. And the kind of questions here that the kind of were central to fact checking this are basically the causality here. Is it the case that the ban was directly linked to these outbreaks, or was something else going on at the time, right? And is there truly a correlation between these? And this is something that GPT-4 does a good job at. It says, when did this happen? Like, what time period? Okay, so like, can we establish that these were temporally the same? can we show an increase, and then can a direct causal link to the bag ban be proven, right? So even though there's kind of nothing about the causality here, like it's able to sort of brainstorm the right questions. Okay, let me show you the kind of second part of this, which is the notion of getting these explainable judgments, right? So we need to then take information that we find and all of these questions and actually assemble them into something coherent to show to a user. So what we do in the system that we put together is we take all of these different subclaims or sub-questions. We kind of frame them differently, whether they're sort of parts of, whether they're framed as statements or questions, and some of our work has used sort of different techniques. We take those things, we feed them into a commercial search engine, and then we retrieve a bunch of documents. And then we essentially take those documents and produce these little summary snippets with ChatGPT, which helps us actually figure out, okay, for each of these questions, what's the kind of relevant information? What does each document have to say about this claim? And how do we understand how these kind of pieces fit together? And so what this looks like is it looks like getting these search results and then producing these little briefs that tell you why that document might or might not be relevant for a claim. So what we do here is actually a little bit less ambitious than it could have been. What we don't do is we don't feed all this information to GPT-4 and say, is the claim right or wrong? And the reason is because we saw that bringing up this hallucination problem again. It would like to kind of spin all these documents together into some kind of narrative, but that narrative wasn't always supported. So instead, we kind of backed off a bit. We said, well, that should really be the job of the human fact checker to figure out what's the final word on this. Instead, what we're going to do is primarily use GPT-4 to sift through the information and kind of figure out how to triage it. Okay, so let me kind of, without further ado, show you what these pieces look like. Unfortunately, there's a lot of text here because that's just the nature of the kind of beast that we're dealing with. But so we have a system here which basically it allows you to kind of enter arbitrary claims. This version of the system I'm showing you here, we kind of pre-ran the queries over a whole bunch of claims here just because of like how we wire it up with the different APIs. This is what's easiest to show. So the one I'm showing here is this plastic grocery bag, and I realize I should make this much bigger so people can actually see. We select this claim, and then there are basically the kind of final outcome of the system is a summary of some of these different documents with links to these original articles. So it says a research paper found there was a spike in San Francisco emergency room treatments in E. coli and an increase in foodborne illness deaths. 8% of reusable shopping bags included E. coli. And if we go to this, we can get this article from the Huffington Post, which kind of sourced this information. And so I'm not going to kind of go through all the pieces, but we have the rest of these documents here as well. Now, this is the kind of the sort of workhorse, this like sub-question generation piece of the system, where we generate these different questions that help us retrieve the actual useful information here. Basically, in this case, we asked, did they ban grocery bags? And that surfaces things. The two I want to show here are, did the number of people going to the ER for salmonella and other related illnesses increase after the plastic bag ban? And it is able to kind of, surface a snippet of an article that talks about the consequences of it. And then, where's the other one? Was the plastic bag ban associated with any other public health issues in San Francisco? It talks about E. coli, right? So the original claim was talking about salmonella. One of the kind of valuable things about these systems from the perspective of search and retrieval is they're able to actually do a good job of kind of using the semantics of the text a little bit better than conventional search engines. And so we can say, okay, we want to find other things. Well, we can surface stuff about, for example, E. coli. Okay. This was another one with the kind of an election clerk in Green Bay refused to allow early voting because she was afraid it would help Democrats, showing outrageous partisan bias. Again, we're able to kind of pull up these different documents that are, that kind of express different aspects of this here. And I guess I'll just show you that if we take, one of these here, it kind of surfaces this stuff, and then basically in the kind of back end here, it's taking these search results and it's crunching the kind of sub questions right now. So we need some kind of progress bar or something to show how long it's actually taking here, but it will, in a few seconds, which I may not wait for given the time, it will kind of pull up what we were looking at before. Okay. Let me kind of just kind of wrap up here, and then we can leave a little bit of time for questions. So in the paper, which is upcoming at NACL 2024, we did an evaluation of basically how reliable the things that we were producing are. And the nice thing is that because we're not using the system to try to like do the entire process end to end, because we're just saying, all right, give me a summary of what's going on, we're able to get what we call faithful summaries a lot of the time. They accurately reflect the content of the documents. So there's not a lot of hallucination or sort of completely wrong things. And then how much of the claims are we able to cover? This is where it looks a little bit less good. But it's also, fact checking is very difficult. So we're able to address roughly half of the claims in our data set and kind of partially address another fraction. But there's a bunch that are just totally, we can't deal with. The information is not out there. And this is, again, where the integration with human fact checkers becomes really key, because this process is just fundamentally not fully automatable. So we've been working as part of our team's advisory council, particularly with David Corney and Scott Hale, and we showed this demo to them, and they kind of gave some pointers about how particularly this could be useful for organizations trying to train more novice fact checkers to kind of produce things that are at a high level and work efficiently in their work here. So the places that we're kind of looking to improve things right now, again, I mentioned that there are still some issues with this question generation phase. We would like to do a bit better job of targeting really the right implicit factors and kind of zeroing in on what's really needed there. So that's one big thing. And then also retrieval. Large language models are very good at like generating stuff, but we actually haven't improved the fundamental retrieval technology of like figuring out how to what to feed into them quite as much in recent years. And so getting those documents and those articles and figuring out how to exactly surface the right stuff, particularly for these very complex fact-checking cases, is something that we're actively working on now, hoping to have something to show in a couple months. Okay, so just to wrap, I think the new wave of generative AI tools has great potential to help fact checkers. It can help with this process of breaking down claims. They can help sifting through and summarizing the information that comes back. And despite the issues with factuality, if we use these models in the right way, they're factual enough to be useful. But still, the kind of questions of how we actually wire this all up in production is sort of an open one, and that's something that we're hoping to address going forward. Thank you.
Hi, my name is Leah. Really, my main question is garbage in, garbage out. So even though I understand that once you get, how do you get to the point of what you're feeding in is okay? So, so HuffPost, okay, we're all happy with that. But, HuffPost AB, which is, a made-up thing, could have lots of garbage.
Yeah, that's a really good question. I think it's one that we've actually really wanted to study, but there's sort of paradoxically, it's a little bit difficult. So we are using a commercial search engine here, which is Bing, just because it has a good API that's easy to use. Bing does a decent job of filtering out like totally like kind of bogus stuff. Like they've already I mean that's their job of their product. So typically when you Google these things, you do, or Bing them, you do tend to get more trustworthy, more reliable stuff. So actually we kind of want to swap in a crappier search engine to see if we can try to address that problem, but it's just been a little bit tough with the system we've got now because it's pretty good at it. But you're 100% right, and particularly in things like scientific fact-checking, where you have, published papers, but you don't know how trustworthy they are or what the affiliations of the authors are and whether they received funding for this work. There's a ton of questions around this that would be great to dig into.
Hi, my name is Wendy. I'm a master's student at School of Information. So first of all, I really like how you are decomposing the article or the claim to sub-questions, because I was also thinking what is a good way to handle disinformation and misinformation. So I think this decomposition is a good start. And as you just answered that, sometimes we can search for some backup articles, but we don't know how credible they are. Do you have any suggestion? Is there any way that we can filter out those written by non-trustworthy ones? Because everyone can write on the internet, and if it's a fake claim, we don't even know, but the search engine will give this to us.
Yeah, I think there's so I think as a sort of, technical natural language processing researcher, I would really like there to be, some deep thing here where we have to find kind of non-factual statements or contradictory or do some linguistic analysis of the style or whatever. I mean, a lot of it, I think, Matt Leese's group has done work on kind of trustworthiness of different sources and kind of detecting stances of things online and stuff like that. I mean, a lot of it does boil down to just knowing a priori which sources are trustworthy and which aren't. So, I mean, there are definitely cues where you can look for things written in a more kind of inflammatory and less neutral style, maybe. But yeah, I mean, again, I think at least in the vein of work we've been doing, there's not been a good kind of data set or quantitative way to get at it. And so that's really something that we're going to try to figure out how to tackle going forward. Okay. Yeah, this will be the last question.
Different languages. How able would this be able to flip between different languages?
Yeah, that's a great question. So one of the people on our advisory council, Laura Zommer, works on fact checking in Latin America, and we would like to sort of try out this technology there. Now that we have these systems like GPT-4, previously we were kind of relying on a fine-tuned system that used this English data, but I mean, GPT-4 can do stuff in Spanish, for example. What's the level of quality? That's an open question that we would love to evaluate. So, I mean, I think the potential is there. Usually it sort of works a little bit less well, and kind of how much less depends on the language, but it would be great to evaluate. Okay, yeah, thanks a lot.